This is an easy lesson. Solution sets to equations with two variables. The key to this is they are ordered pairs. We can substitute into check. So with 3, 2, we're seeing if it works. 4 times 3 is 12, minus 2 is 10. Hot darn. 4 times 2 is 8, minus 3. 8 minus 3 is 5. 5 does not equal 10. 4 times -1 is -4, minus a -14. So -4 minus a negative. So that's -4 plus 14. Oh, perfect. 4 times 0 is 0. 0 minus 0 is not even close to 10. 4 times 1 is 4, minus a -6. 4 minus a -6 is like saying 4 plus 6. That works. 4 times 5 is 20. 20 minus 10 is 10. Love it. 4 times 0 is 0, minus a -10. So 0 minus a -10 is 10. Wow, this is getting easy, Mr. H. 4 times 3 is 12, minus 4 is 8. Nope. 4 times 6 is 24, minus 0 is 24. Nope. 4 times 4 is 16, minus a -1 is actually going to be 17. Nope. All you're doing is substituting into both the x and the y to see if it works. Now, some of you might be saying, Mr. H, this right here looks familiar, as it should. This is what's called standard form. You could put this into slope-intercept form and say it's y equals 4x minus 10. And that would be a wonderful, wonderful, wonderful thing to do, because here's my y-intercept, 0, -10. Oh man, we have that point. So why is that going to be important? Well, stick around, let's find out. So this section does not talk a lot about slope-intercept form, but know that you can put slope-intercept form into it. So maybe, there we go. Okay, don't care, don't care, don't care, don't care. Don't care. Okay, do care. Well, now we get to something that's not as exact. Create an equation using two variables to represent the situation. Be sure to explain the meaning of each variable. The sum of two numbers is 25. So the sum means we are adding two numbers. So we're going to say x plus y equals 25. X equals a number, y equals another number. This is my equation. We know two numbers are going to give me this, right? We know that based off of this graph that we have, we could have several different things. So I'm going to count by fives just to make this easy. 5, 10, 15, 20, 25. So here's my x, here's my y. What are some of our options? Well, if x is 0, y would have to be 25. So I can go 0, 25 with a point. Okay? So let's at least 6 solutions. 0, 25. What's another one? Well, let's stick in multiples of 5 because we know this is 5, 10, 15, 20, 25. Okay. Well, what about 5 is x? This would be 20. Okay? So now I'm going over 5, 20. Oh, so far so good, okay. How about 10 and 10? Sure. Love it. So 10, 10. Well, Mr. H, that would be 20, you numbskull. How about 10 and 15? Because that would make much more sense, right? Well, only if I did this right and knew math. Hooray me. It's been a long day, whatever. What about 15 and 10? Oh, so now I'm going over 15 up 10, which means 20 up 5, 0, 25, 1, 2, 3, 4, 5, 6. Hey, look at all these that I've got. But Mr. H, why are you still going negative? Well, couldn't some of my y's be negative? Couldn't I go this way and some of my x's be negative? Sure. This is why graphing is important, because everywhere on this graph, and let's see if I can actually make a solid line here. So my wife called me in the middle of the video. You saw me having this thing up here, so I've drawn this line. Well, what does this line represent? This line, everywhere this line hits, is a point. So if we're counting by fives, this is 5, 10, 15, 20. This is negative 25. So if I have negative 25 on the x, what do I have to, or on the y, what do I have to have on the x? 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. Does 50 plus negative 25 still give me 25? Absolutely. The key here is to know that everywhere on the line, anywhere on my graph, is an answer to this equation. That's so, oh man, my whole thing's tipping. It's so important to understand that when we graph linear equations, everywhere on that line is actually a solution. This is a perfect example to think about because everywhere it's at, here's negative 5 up 30. So negative 5 for my x plus 30 is 25. That's a solution. And I can keep doing that. Here's a point. This is at negative 5, 10, 15, 20. This is at negative 20 plus 1, 2, 4, 5, 6, 7, 8, 9, which is 45. Which makes sense. Negative 20 plus 45 is positive 25. This is making a graph. Okay? I love it. Let's move on. Okay, this is the same type of thing. I don't know why we would do this. Now, the difference is, let's read this question and then think about common sense. So I'm not going to necessarily do the problem because it's important that you understand common sense, which most of you do. Some of you don't, but we'll figure that out later. We're talking about 25 songs in a playlist. So when we're talking about songs, and why is this tilting and not staying up? I don't know. If we're talking about 25 songs in a playlist, can we still use the x plus y equals 25? Sure. But when we start to graph it, can we have something? So we have quadrant 1, 2, 3, 4. Are we going to be able to have that 50, negative 25? Well, no, because you can't have negative 25 songs by somebody. So all of the answers would stay here in quadrant 1. You need to understand, hey, sometimes things can be negative. When we're talking about the number of songs, you can't have negative songs. So it's about common sense, okay? What will make sense when I actually graph it? The numbers, we can have positives and negatives. Songs, we can't. You just have to understand those small little things. That's it for this lesson, folks. Have a great day.